Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over a special video requested by one of our students from our program targeting tricky trig identities, specifically those with higher degrees. If you're somebody who's new to this channel, we post videos like this every Monday to Friday at 3 p.m. Eastern. And if you have questions, guys, and need tutoring, feel free to click the link in our description, and our tutoring team would love to get in touch with you guys. But without further ado, let's get straight into the video. So we have a trig identity where we're using higher degrees. Notice how on the left side, we have this to the power of 6 going on in the exponent. So a lot of students see these questions, especially on the thinking part of their test, and they get really stuck. But here is a simple way on how we're going to solve this. The first thing you want to do is you want to do this manipulation. Instead of saying sine 6x, you're going to say this is the same thing as me saying sine squared x to the power of 3. And with the same thing, you're going to do the same to cos as well. The reason I made this manipulation is because I want this to resemble a sum of cubes. Okay? I want to resemble a sum of cubes. So let's go over what is a sum of cubes for those of you guys who don't remember. A sum of cubes is where you have something like this, a cubed plus b cubed, and this is equivalent to a plus b, a squared plus ab, a squared minus ab, plus b squared. So this is a sum of cubes. This is the formula for a sum of cubes. Now, in this case, we're going to say that a is going to be our sine squared x, and b is going to be our cos squared x. So now, if we treat this as a sum or difference of cubes, this a and b are going to be what we're going to plug in as these points. This is how you unlock the question, and then the rest becomes a lot easier. So let's unlock that. So we have a plus b, so it's going to be sine squared x plus cos squared x, bracket sine squared x squared minus sine squared x cos squared x plus cos squared x squared. And all I did was I used that sum of cubes. Now, with this, I know using the Pythagorean identity, the sine squared x and the cos squared x is just going to give us 1 using Pythagorean identity. So we remember Pythagorean identity is when sine squared x plus cos squared x is equal to 1. Okay, so all I'm really left with now, guys, is this right here. So now we're going to do a little bit of simplification. So this is going to be sine to the 4x minus sine squared x cos squared x plus cos to the 4x. Now notice at this point in the question, guys, I'm looking at this, and remember, I'm trying to make this left side equal this right side. And if you notice in the right side, everything is in sines, right? There's no cos x's in the right side. So what I want to do with my equation is I want to take these cos x's and I want to make them into sine x's. Okay, so let's do that first. So this is what I'm going to do. I'm going to say sine 4x minus sine squared x. The cos squared x I'm going to turn into 1 minus sine squared x using my Pythagorean identity. And this is the same thing as saying cos squared x times cos squared x. And the reason I'm writing it out like this is because you're going to see in the next step what I do. Sine squared x, 1 minus sine squared x, plus cos squared x, which is 1 minus sine squared x times 1 minus sine squared x. Okay, so now let's clean this up a little more. You end up with sine 4x minus sine squared x plus sine 4x plus 1 minus 2 sine squared x plus sine 4x. So notice, guys, over here, this right here, I just expanded it out to be that. And this right here, I expanded it out to be that. Okay, Now we're just going to clean it up. So sine 4x plus sine 4x is going to give me we have 3 of them. So we got, here I'll show you, we got sine 4x, sine 4x, sine 4x, which is going to give us our 3 sine 4x. And then we got negative sine squared x minus 2 sine squared x, which is going to give us minus 3 sine squared x. And then we have the 1, which is just going to be the plus 1. And if we rearrange this, right, with our terms, we'll literally end up with the right side, which is 1 minus 3 sine squared x plus 3 sine 4x. And there you have it. That's your answer. Left side equals the right side right here. So notice this type of problem, guys. If you didn't know how to see the sum of cubes kind of formulating right off the bat, you would not know how to do this question. So the sum of cubes is essential to do this question. That's what unlocks the problem. So this is why it's important for you guys to memorize what is the sum of cubes, right? If you didn't know that a cubed plus b cubed gives you that a plus b times the a squared minus ab plus b squared, then you're not going to know how to do the problem. And then the rest of the problem, guys, over here is just simplify. You're just simplifying, right? There's no science to this whatsoever. Okay, so let's try another example with higher degrees. And this is another question that we've gotten from our students that I think would be valuable for you guys to understand. So here we have a little bit of a different situation. We have secant 6x minus tan 6x. So this, instead of a sum of cubes, it's going to be a difference of cubes. So what I'm going to say here is I'm going to say let a is equal to, so we're going to say this is secant squared x cubed minus tan squared x cubed. So a is going to be secant squared x and b is going to be tan squared x. Now what we're going to do is, since we know that it's a difference of cubes, it's going to be a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. And we're going to use a, which is secant squared x, and b, which is tan squared x, and we're going to plug it into this equation in the exact same way. Okay? So let's look at this. A, we have secant squared x minus tan squared x times secant squared x plus secant squared x tan squared x plus, this is secant squared x squared, and this is going to be tan squared x squared. Okay. Now, using Pythagorean identity, we know secant squared x minus tan squared x is also equal to 1 using Pythagorean identity. Okay? So if you didn't know this identity, you're not going to know how to just completely cancel it out. So then what are we left with? We're left with secant squared x. We're left with just this right here. So now what I want to do is a little bit of a manipulation. Over here, I'm going to say that this secant squared x is 1 plus tan squared x squared. So notice I changed this to this. And then I'm going to say plus secant squared x, tan squared x, plus tan 4x. Okay, and I'm going to show you why I did this. The reason I left this guy alone was because I saw in my answer for the right side, I saw that I still have that there. There is a tan squared x, secant squared x, or secant squared x, tan squared x. There is something there. So I don't want to touch that because it's already close to the answer. So I'm going to deal with the other terms and see what I get from there. So now over here, the 1 plus tan squared x, I'm going to just expand this out. So you have 1 plus tan squared x times 1 plus tan squared x plus secant squared x, tan squared x plus tan 4x. And then from here, I'm going to FOIL this whole thing out. So I'm going to FOIL this, out, and what do I end up with? I end up with 1 plus 2 tan squared x plus tan 4x plus secant squared x tan squared x plus tan 4x. And from here, I'm going to group my like terms. So I get a tan 4x and a tan 4x. So I'll end up with 1 plus 2 tan squared x plus 2 tan 4x plus secant squared x tan squared x. Now this is interesting, right? If I look at my answer, notice the secant squared x, the tan squared x, secant squared x is here, but I also have that here. I also have a 1 in there, and I also have the 1 in here. So the only thing left for me to do is really target this purple thing right here, because this is where the question's going to unfold. So what I would do in this case is I would actually factor out a 2 tan squared x, and what I'll be left with is a 1 plus tan squared x. So I factored out a 2 tan squared x from the purple. So this is just equivalent to whatever I did in the purple. Okay. So the reason I did this is because if you know your Pythagorean identity when it comes to secant squared x and tan squared x, you're going to know that this is actually secant squared x. So see how this plays out. You get 1 plus 2 tan squared x, secant squared x, plus secant squared x, tan squared x. And if you notice, this right here is where you get the 3 tan squared x, secant squared x. So then you have your answer, 3 tan squared x, secant squared x. So this right here is your answer. Left side equals right side, and you're good. So notice how, right, when you have these higher degree functions, a lot of the times you're going to need to use a difference of cubes, a sum of cubes, a difference of squares, a sum of squares. The question is baiting you into using that. So you have to know, as a student, you got to know that's what's coming, right? So when you see these kinds of questions on the test, don't get scared. Just have this in your back pocket so that when it does come, you're not afraid of the moment and you can answer the question with confidence. Now, if you found this video helpful, guys, it would really support the channel if you dropped a thumbs up, commented your thoughts. If you have questions that you want me to go through, I'd love to do them on this channel. And feel free to share this to someone, one of your classmates, one of your friends who may need help with this course. But without further ado, I'll see you guys in the next video.